Technology Risk Part 3. This episode has 21 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Risk assessment. What is scenario analysis? Here's a strong way to approach it. Scenario analysis evaluates realistic risk events and their consequences. For example, what happens if a public bucket exposes customer data? Or what if Terraform state is modified incorrectly? It helps teams think beyond control checklists and understand business impact, response steps, recovery plans, and control gaps. Nice. Let's continue. Question 2. Risk assessment. Explain risk acceptance, avoidance, mitigation, and transfer. Here's a strong way to approach it. Risk acceptance means leadership knowingly accepts residual risk. Avoidance means stopping the risky activity. Mitigation means reducing likelihood or impact through controls. Transfer means shifting some risk through insurance, contracts, or vendors. For critical technology risks, mitigation is usually preferred unless there is a documented business reason for acceptance. Great. Moving on. Question 3. Risk assessment. Give an example of a risk you mitigated. Here's a strong way to approach it. A strong example would be overprivileged cloud service accounts. I would identify risky permissions through IAM analysis and audit logs, map actual usage, replace broad roles with least privileged custom roles, remove unused keys, enforce workload identity, add monitoring for privilege changes, and track the remediation as a measurable reduction in access risk. Alright, next question. Question 4. IT controls. What are preventive controls? Here's a strong way to approach it. Preventive controls stop a risk event before it occurs. Examples include least privilege IAM, policy as code checks, required approvals, network restrictions, encryption requirements, branch protection, and admission policies. In cloud environments, preventive controls are valuable because they reduce dependency on manual review. Let's keep going. Question 5. IT controls. What are detective controls? Here's a strong way to approach it. Detective controls identify when something risky has happened. Examples include audit logs, SIM alerts, cloud logging, vulnerability scans, drift detection, access review reports, and anomaly detection. They do not prevent the issue directly, but they reduce detection time and support investigation. On to the next one. Question 6. IT controls. What are corrective controls? Here's a strong way to approach it. Corrective controls restore the environment or reduce damage after a risk event. Examples include incident response, automated rollback, patching, secret rotation, access revocation, backup restoration, and post-incident remediation. Good corrective controls reduce recovery time and prevent recurrence. Good. Here's another one. Question 7. IT controls. Give examples of each control type in cloud infrastructure. Here's a strong way to approach it. Preventive controls stop an issue before it happens. Org policies blocking public IPs. IAM least privilege bindings. Required CI or CD approvals. Detective controls identify issues after the fact. Security command center findings. Audit logging. Anomaly detection alerts. Corrective controls fix an identified issue. Automated remediation scripts. Incident response runbooks. Patch deployment. A mature cloud security posture layers all three together for each major risk area rather than relying on preventive controls alone. Nice. Let's continue. Question 8. IT controls. How do you validate control effectiveness? Here's a strong way to approach it. I validate effectiveness by checking evidence, testing the control, reviewing logs, sampling transactions, and confirming that failures are detected and remediated. For example, for deployment approval, I would inspect pipeline configuration, recent deployment records, approval evidence, exception handling, and whether unauthorized deployments are blocked. Great. Moving on. Question 9. IT controls. What is segregation of duties? Here's a strong way to approach it. Segregation of duties means no single person should control an end-to-end sensitive process without oversight. For example, The same developer should not be able to write code, approve it, deploy to production, and change production access without review. In CI or CD, this can be enforced through branch protection, approvals, and limited production permissions. Alright, next question. Question 10. IT controls. What is least privilege? Here's a strong way to approach it. Least privilege means granting only the permissions needed to perform a task and nothing more. It reduces blast radius if an account or workload is compromised. Detailed interview explanation. Least privilege should be explained from a production troubleshooting and security perspective. These questions test whether you understand operating system fundamentals, networking behavior, access control, and how to debug safely under pressure. Production example. If a service is slow or down, you may check service state with systemtl, logs with journaltl, processes with top or top, memory with free and mstat, disk with df and iostat, sockets with ss, DNS with dig, connectivity with curl or nc, and packets with dump. For security topics, connect the answer to least privilege, hardening, encryption, segmentation, patching, and audit logs. Best practices to mention. Start with impact, recent changes, logs, metrics, and resource saturation. Validate DNS, routes, firewall rules, TLS certificates, and dependency health for network issues. Use least privilege, patching, MFA, secrets management, and logging for security. Automate repetitive operational tasks with scripts and runbooks. Avoid risky production commands unless you understand blast radius and rollback. Common interview follow-ups. Interviewers may ask how to debug high CPU, memory leaks, disk full, inode exhaustion, DNS failures, packet loss, TLS issues, SSH access problems, or suspicious activity. Strong answers are step-by-step and evidence-driven. Let's keep going. Question 11. IT controls. Explain RBAC. Here's a strong way to approach it. RBAC stands for Role-Based Access Control. It assigns permissions through roles mapped to users, groups, or service accounts. In Kubernetes, RBAC uses roles, cluster roles, role bindings, and cluster role bindings. Good RBAC design separates admin, developer, CI or CD, read-only, and security responsibilities. On to the next one. Question 12. IT controls. What are compensating controls? Here's a strong way to approach it. Compensating controls are alternative controls used when the preferred control is not feasible. For example, if a legacy system cannot support MFA, compensating controls could include VPN restriction, privileged access monitoring, short-lived credentials, strong logging, and frequent access reviews. They should be documented and time-bound. Good. Here's another one. Question 13. IT controls. How do you monitor control failures? Here's a strong way to approach it. I monitor control failures through alerts, dashboards, exception reports, audit logs, periodic control testing, and ticket workflows. Examples include failed backup jobs, disabled logging, policy violations, expired certificates, unpatched systems, or overdue access reviews. Control failures should have owners, severity, SLA, and escalation paths. Nice. Let's continue. Question 14. SDLC or secure development. How do you integrate risk into SDLC? Here's a strong way to approach it. I integrate risk at each phase: requirements, design, development, testing, release, and operations. During requirements, I review data and regulatory impact. During design, I review architecture and threats. During build, I use secure coding, scanning, and peer review. Before release, I check controls, evidence, rollback, monitoring, and ownership. Great. Moving on. Question 15. SDLC or secure development. What risks should be reviewed during BRD or PRD? Here's a strong way to approach it. I review data sensitivity, business criticality, customer impact, regulatory needs, authentication, authorization, integrations, third-party dependencies, availability requirements, logging, retention, and operational support. Early review prevents expensive rework after design or implementation. Alright, next question. Question 16. SDLC or secure development. How do you review architecture from a risk perspective? Here's a strong way to approach it. I review identity, data flows, trust boundaries, network exposure, encryption, logging, resilience, dependencies, secrets, deployment process, and operational ownership. I ask what can fail, what can be abused, how it will be detected, how it will be recovered, and who owns each control. Let's keep going. Question 17. SDLC or secure development. What security controls should exist before production deployment? Here's a strong way to approach it. Required controls include strong IAM, secrets management, encryption, vulnerability scanning, secure CI or CD, approval gates, logging, monitoring, alerting, backup and restore, rollback plan, network restrictions, data protection, and incident runbooks. For regulated systems, evidence and control sign-off should be captured before release. On to the next one. Question 18. SDLC or secure development. Explain secure SDLC. Here's a strong way to approach it. Secure SDLC embeds security and risk controls throughout software delivery instead of checking at the end. It includes secure requirements, threat modeling, secure coding, code review, SAST, dependency scanning, container scanning, secrets detection, DAST where relevant, release approvals, and post-production monitoring. Good. Here's another one. Question 19. SDLC or secure development. What are threat modeling techniques? Here's a strong way to approach it. Common techniques include STRIDE, attack trees, data flow diagrams, abuse cases, and kill chain analysis. I use threat modeling to identify how a system can be attacked or misused, especially across trust boundaries like internet entry points, APIs, service accounts, and data stores. Nice. Let's continue. Question 20. SDLC or secure development. What is STRIDE? Here's a strong way to approach it. STRIDE is a threat modeling framework. Spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. It helps systematically identify threats and map them to controls such as authentication, integrity checks, logging, encryption, rate limiting, and least privilege. Great. Moving on. Question 21. SDLC or secure development. What is attack surface? Here's a strong way to approach it. Attack surface is the total set of entry points or weaknesses an attacker could use. Examples include public endpoints, APIs, service accounts, open ports, CI or CD secrets, admin consoles, and third-party integrations. Reducing attack surface means removing unnecessary exposure and hardening what remains. Alright, next question. That wraps up this episode. Nice work practicing, and see you in the next one.